Supercharging versus turbocharging. Keeping the air that enters the engine cool is an important part of the design of both superchargers and turbochargers. Compressing air increases its temperature, so it is common to use a small radiator called an intercooler between the pump and the engine to reduce the temperature of the air. There are three main categories of superchargers for automotive use. Centrifugal turbochargers, driven from exhaust gases. Centrifugal superchargers, driven directly by the engine via belt drive. Positive displacement pumps, such as the Roots, twin-screw, lithium, and TVS, Eaton, blowers. Roots blowers tend to be only 40 to 50% efficient at high boost levels. By contrast, centrifugal, dynamic, superchargers are 70 to 85% efficient at high boost. Lithium-style blowers can be nearly as efficient as their centrifugal counterparts over a narrow range of load/speed/boost, for which the system must be specifically designed. Mechanically driven superchargers may absorb as much as a third of the total crankshaft power of the engine and are less efficient than turbochargers. However, in applications for which engine response and power are more important than other considerations, such as top fuel dragsters and vehicles used in tractor pulling competitions, mechanically driven superchargers are very common. The thermal efficiency, or fraction of the fuel-air energy that is converted to output power, is less with a mechanically driven supercharger than with a turbocharger, because turbochargers use energy from the exhaust gas that would normally be wasted. For this reason, both economy and the power of a turbocharged engine are usually better than with superchargers. Turbochargers suffer, to a greater or lesser extent, from so-called turbo spool, turbo lag, more correctly, boost lag, in which initial acceleration from low RPM is limited by the lack of sufficient exhaust gas mass flow pressure. Once engine RPM is sufficient to raise the turbine RPM into its designed operating range, there is a rapid increase in power, as higher turbo boost causes more exhaust gas production, which spins the turbo yet faster, leading to a belated surge of acceleration. This makes the maintenance of smoothly increasing RPM far harder with turbochargers than with engine-driven superchargers, which apply boost in direct proportion to the engine RPM. The main advantage of an engine with a mechanically driven supercharger is better throttle response, as well as the ability to reach full boost pressure instantaneously. With the latest turbocharging technology and direct gasoline injection, throttle response on turbocharged cars is nearly as good as with mechanically powered superchargers, but the existing lag time is still considered a major drawback, especially considering that the vast majority of mechanically driven superchargers are now driven off clutched pulleys, much like an air compressor. Turbocharging has been more popular than superchargers among auto manufacturers owing to better power and efficiency. For instance, Mercedes-Benz and Mercedes-AMG previously had supercharged compressor offerings in the early 2000s, such as the C230K, C32AMG, and S55AMG, but they have abandoned that technology in favor of turbocharged engines released around 2010, such as the C250 and S65AMG bi-turbo. However, Audi did introduce its 3.0 TFSI supercharged V6 in 2009 for its A6, S4, and Q7, while Jaguar has its supercharged V8 engine available as a performance option in the XJ, XF, XKR, and F-Type, and, via joint ownership by Tata Motors, in the Range Rover also. Twin charging. In the 1985 and 1986 World Rally Championships, Lancia ran the Delta S4, which incorporated both a belt-driven supercharger and exhaust-driven turbocharger. The design used a complex series of bypass valves in the induction and exhaust systems as well as an electromagnetic clutch so that, at low engine speeds, boost was derived from the supercharger. In the middle of the rev range, boost was derived from both systems, while at the highest revs the system disconnected drive from the supercharger and isolated the associated ducting. This was done in an attempt to exploit the advantages of each of the charging systems while removing the disadvantages. In turn, this approach brought greater complexity and impacted on the car's reliability in WRC events, as well as increasing the weight of engine ancillaries in the finished design. The Volkswagen TSI engine, or twin-charger, is a 1.4-liter direct injection motor that also uses both a supercharger and turbocharger.